Welcome, friend, and thank you for being here in this quiet corner of the internet. This is Whispers of Science, a place where we slow down, breathe deeply, and let curiosity carry us through the mysteries of the universe. Before we begin tonight's journey, I want to share something personal with you. This little channel is still very young, almost like a newborn star just beginning to glow in the darkness. My dream is to see it slowly grow brighter, step by step, person by person. Right now, the next milestone is small but meaningful, just 20 subscribers. That's all. 20 people who enjoy these calm explorations enough to stay with me for the journey ahead. If you find comfort in these stories, if they help you relax at night or spark your imagination during the day, I would be so grateful if you would subscribe. It's not just about a number, it's about building a gentle community of curious souls. And if you'd like to feel even more connected, leave a comment telling us where you're listening from and at what time. Maybe you're lying in bed as the night settles in. Maybe you're on a quiet afternoon break, or perhaps it's early morning and the world is just waking up. Imagine scrolling through those comments and realizing you're part of a web of listeners across the world. Different places, different times, but all gathering here in this moment. It's a reminder that none of us are truly alone. With that thought, let's step gently into tonight's journey. 100 calming facts about Earth you've never heard before. We'll start close to home, our Earth itself, and slowly drift outward into the wider cosmos. Each fact is like a soft stepping stone, leading us deeper into wonder. Let's begin. Did you know that the Earth hums? Not in a way we can hear with our ears, but as a very faint vibration, a constant low-frequency sound that scientists have measured through sensitive instruments. It's as though our planet itself is singing a song so deep and steady that it becomes the background music of existence. No one fully understands all the reasons for this hum, though ocean waves and vibrations deep in the crust play a part. It's humbling to imagine that even when the world seems silent, there's a hidden music carrying on beneath our feet. Our planet also carries stories in its stones. Beneath the surface, there are crystals older than any mountain range, tiny zircons that date back over 4 billion years. That's almost as old as the Earth itself. Imagine holding one of those crystals in your hand, a fragment of the earliest Earth, a survivor of fire and chaos whispering across time. The oceans, too, hold secrets beyond counting. For instance, the longest mountain range on Earth is not the Himalayas, but the Mid-Atlantic Ridge, a chain of mountains stretching for more than 40,000 miles, mostly hidden beneath the waves. If we could drain the oceans, the Earth would suddenly look like a planet covered in colossal scars and ridges, shaped by forces far beyond our everyday lives. Even the air we breathe tells a story. Every breath you take contains atoms of oxygen that once flowed through ancient forests, through dinosaurs, through distant seas. In fact, scientists estimate that each breath you inhale right now likely contains at least one molecule of oxygen that once passed through the lungs of someone in history, perhaps an emperor in Rome or a traveler in ancient Egypt. In this way, the air itself is a bridge across time, connecting us to every creature that has ever lived. Here's another quiet wonder. Trees can speak in their own language. Not with words, of course, but with chemistry. A tree under attack by insects will release specific scents, tiny invisible signals, warning its neighbors of danger. In response, the surrounding trees may begin producing bitter compounds to make their leaves less tasty. It's like a silent forest conversation carried on without a sound, weaving together life in a hidden web of defense and cooperation. And while trees stand tall on land, the oceans hold a secret of their own. There is a jellyfish known as Turritopsis dohani, sometimes called the immortal jellyfish. When stressed or injured, it can revert its cells back to an earlier stage of life and start again, almost like pressing a reset button. It's one of the only creatures on Earth known to potentially escape death in this way. Though tiny and fragile, it carries a secret of renewal that feels almost mythical. Let's pause for a moment. As you sit here listening, whether at night or in daylight, think about this. You are part of the same story as crystals older than time, mountains beneath oceans, ancient forests, and even jellyfish that refuse to die. Life on Earth is vast, mysterious, and interconnected. And here you are, breathing, existing, and listening, part of this grand story. As we continue, we'll wander deeper into these calming truths, each one like a soft spark against the quiet of your day. There are many more to uncover, so let's take another gentle step. The universe itself. Now that we've set our feet gently on the soil of Earth and peeked at its hidden wonders, it's time to lean back and look upward. Beyond the blue sky, past the thin shell of atmosphere that shields us, lies the universe itself, boundless, ancient, and stretching farther than our minds can easily grasp. The universe is about 13.8 billion years old. That number feels almost impossible to hold in the mind. To give it perspective, imagine a single calendar year, where January 1st is the birth of the universe and December 31 is today. In that scale, the Earth would not form until early September. Dinosaurs would appear on December 25th. Humans would arrive just minutes before midnight. And everything we think of as history, every empire, every discovery, every personal story, would happen in the final seconds of the final minute. That is how immense cosmic time really is. As for space itself, astronomers speak of the observable universe. It stretches about 93 billion light-years across. A light year, as you may know, is the distance light travels in 1 year, about 6 trillion miles. So when we say 93 billion light-years, the number becomes so huge it dissolves into poetry. It's not just distance. It's a reminder of how small our home is, and here's a thought that may slow your breath. Beyond that observable edge, there may be more, vast expanses of space forever hidden from us, because their light has not yet had time to reach us. The universe is not only enormous, it is also partially invisible, a grand mystery of what lies beyond the horizon. The night sky we see is a kind of time machine. Every star, every point of light is the past delivered to us in real time. The light from the nearest star system, Alpha Centauri, takes over 4 years to reach us. When you look at it, you are looking 4 years back. The light from the Andromeda Galaxy takes more than 2 million years to arrive. So when you gaze at it through a telescope, you are not seeing it as it is tonight, but as it was when early humans first began to use stone tools. Astronomy is not just about space, it is about time stitched into every glimmer of starlight. Another calming truth is that the universe itself is expanding. The galaxies are not just sitting still, they are being carried away from each other as space itself stretches. Imagine dots on a balloon. As the balloon inflates, the dots move farther apart, not because they're running, but because the balloon itself is stretching. This discovery, made by Edwin Hubble in the 1920s, was one of the most profound realizations in human history, that the cosmos itself is dynamic, alive and always moving, and the expansion is not slowing down, it is accelerating. Something mysterious called dark energy is pushing the universe apart faster and faster. We don't know what it is. It may be the energy of space itself. It may be something even stranger. But what matters for us sitting here tonight is the knowledge that the universe is not static. It is an unfolding story, a river that flows outward forever. Here's another fact to let your mind rest upon. Most of the universe is invisible. About 95% of it is made of things we cannot see or touch, dark matter and dark energy. The stars, planets, and gas, we know, make up only 5%. That means everything we have ever seen, the Earth, the Sun, all the galaxies, are just a small fraction of what exists. It's as though we live in a house where only one tiny room is lit, while the rest stretches into darkness. Even though this may sound unsettling, many people find it deeply calming. Because the unknown does not always mean danger, it can also mean wonder. The universe is vast, yes, but it is also elegant, woven together with laws of physics that hold steady no matter where we look. Gravity, light, and time behave the same across billions of light years. There is comfort in that constancy, like a steady rhythm that beats beneath everything. Let's pause for a moment. Imagine yourself lying on your back beneath the night sky. Above you, countless stars shimmer, each one a sun in its own right. Some have planets, perhaps even life. Others are alone. Their light may have traveled for centuries or millennia just to reach your eyes in this quiet moment. You are both tiny and infinite, small in size yet connected to all of it. The universe may be vast, but in moments like this it feels close. The same atoms that make up your body were forged in the hearts of stars. The iron in your blood, the calcium in your bones, the oxygen you breathe, all of it was born in cosmic furnaces billions of years ago. Carl Sagan once said, "We are made of star stuff." It is not just poetry, it is literal truth. You are the universe, aware of itself, whispering in the dark. As we continue our journey, let this thought linger. The universe is not something distant. It is within you. Every heartbeat, every breath, every thought is part of this endless cosmos. And as we drift further, we'll leave behind the vast whole and start exploring the islands within it, the galaxies that spin like luminous whirlpools, each one a universe of its own. Galaxies, islands of stars. If the universe is an ocean, then galaxies are its islands, enormous glowing continents of stars, gas, dust, and dark matter. Each one is a city of light floating in the dark, bound together by the quiet pull of gravity. When you look up at the Milky Way, that hazy band stretching across the night sky, you are seeing your own home galaxy from the inside. Astronomers estimate that the Milky Way contains about 100 to 400 billion stars. Even the smaller number is difficult to imagine. If you were to count one star per second without ever stopping, it would take you more than 3,000 years just to count them all. And yet, our galaxy is only one among billions. Observations from the Hubble Space Telescope suggest that the observable universe may contain as many as 2 trillion galaxies, each one filled with its own stars, planets, and mysteries. The Milky Way itself is a spiral galaxy. Imagine a vast pinwheel with arms made of stars curling gracefully outward. From edge to edge, it stretches about 100,000 light years. That means if you could travel at the speed of light, it would still take you 100,000 years to cross it. And our solar system is not at the center, but on the outskirts, about 2/3 of the way out, nestled in a quiet arm called the Orion Spur. Our place in the galaxy is modest, a neighborhood tucked away from the crowded core. At the heart of the Milky Way lies something extraordinary, a supermassive black hole known as Sagittarius A. It has a mass equal to about 4 million suns. Though invisible, its presence is known by the way nearby stars orbit at incredible speeds, as if dancing around an unseen giant. Black holes like this are common in galaxies. In fact, most large galaxies appear to have one anchoring their centers, shaping the rhythm of stars around them. Galaxies come in many shapes beyond spirals. Some are elliptical, smooth and round, holding little dust and few young stars. Others are irregular, chaotic, distorted by cosmic collisions. Galaxies do not live alone. They interact, merge, and sometimes collide in vast cosmic ballets. Our own Milky Way is currently on a slow-motion collision course with the neighboring Andromeda Galaxy. The two will meet in about 4 billion years, merging into a single, larger galaxy. To us, that sounds like a disaster, but it will likely be gentle on the scale of stars. Because galaxies are mostly empty space, very few stars will actually hit each other. Instead, they will drift past, rearranged into new patterns, while the black holes at the centers spiral together into one. Think for a moment of what it means to live inside such a structure. Every star you see in the night sky is a local resident, one of your neighbors in the Milky Way. Beyond that faint band of the Milky Way's light, the sky is filled with galaxies, each a home for billions more stars. To the naked eye, only a few galaxies are visible. The Andromeda Galaxy is the most famous, appearing as a faint smudge on dark nights. But through telescopes, the universe blossoms with galaxies, stretching away like glowing pearls on a string. Some galaxies are truly extraordinary. There are starburst galaxies where stars are being born at furious rates, lighting up the cosmos with youthful energy. Others are dim, their star formation long since ended, glowing faintly with the aging light of red giants. Then there are dwarf galaxies, small companions to larger ones, often swallowed up in mergers. The large and small Magellanic Clouds, visible from the southern hemisphere, are two such companions to the Milky Way, drifting like clouds of stars nearby. And galaxies themselves are not scattered randomly. They gather into clusters and superclusters, vast webs that span hundreds of millions of light years. When mapped out, the universe begins to look like a cosmic tapestry, with galaxies strung along invisible filaments of dark matter, leaving great voids between them. The largest known structure is the Hercules Corona Borealis Great Wall, a galactic filament over 10 billion light-years long. These immense patterns remind us that galaxies are not just isolated points of light, but parts of a larger, interconnected whole. Here's a calming thought. No matter how different galaxies may look, they all follow the same rules of physics. Gravity binds them. Light flows through them. Time moves forward within them. The same laws that shape the Milky Way are at work in distant galaxies, billions of light years away. There is harmony in that constancy, a cosmic order that holds across unimaginable distances. And galaxies, despite their immensity, are also fragile. Collisions, bursts of star formation, and even interactions with invisible dark matter sculpt them over time. They are living systems changing across billions of years. To us, they seem eternal. But like everything in the universe, they are in motion, always becoming something new. As you close your eyes and picture them, imagine standing on a quiet hillside beneath the night sky. Above you, the Milky Way arcs in pale light, a river of stars. Far beyond it, countless galaxies drift in silence, each one a story, each one a world. And you, one small being, are part of this endless archipelago of light. With galaxies explored, we can journey deeper still, for within them lie the engines of creation, stars. In our next section, we'll drift among them, learning how they are born, how they live, and how they die, scattering their brilliance back into the cosmos. Stars, the engines of light. Every night, when we look up at the sky, we are seeing history. The points of light above us are stars, ancient furnaces burning across unimaginable distances. Some of the light you see tonight may have left its star hundreds or even thousands of years ago. Starlight is a message from the past, carried gently across the dark to reach your eyes. And in each star lies a story, not just of fire and fusion, but of creation itself. A star begins its life in a nebula, a great cloud of gas and dust. Within these vast nurseries, gravity pulls matter together, squeezing it tighter until the pressure and heat ignite nuclear fusion. At that moment, a star is born. Hydrogen atoms fuse into helium, releasing energy in the form of light and heat. It is a simple reaction, but one that powers suns and galaxies, shaping the very conditions for life. Our Sun is an ordinary star, a yellow dwarf, yet extraordinary for us because it sustains everything we know. At about 4.6 billion years old, it is in the middle of its life. Each second, it converts 600 million tons of hydrogen into helium, radiating enough energy to warm our planet across 93 million miles of space. Without it, Earth would be a frozen, lifeless rock adrift in darkness. But stars are not all the same. Some are giants, burning with furious intensity. Blue supergiants can shine hundreds of thousands of times brighter than the Sun. Their lives, though, are short, just a few million years before they exhaust their fuel. Others are small and faint, like red dwarfs. These stars burn so slowly that they can last for trillions of years, far longer than the current age of the universe. Imagine a star that will still be shining when everything else has faded away. Stars live by balance. Gravity pulls them inward, while the energy of fusion pushes outward. When that balance is broken, stars change. For some, like our Sun, the end will come gently. It will swell into a red giant, expanding so large it may swallow the inner planets. Then it will shed its outer layers into space, leaving behind a glowing shell of gas called a planetary nebula. At the center, a small, dense remnant called a white dwarf will remain, about the size of Earth, but with a mass close to the Sun's. White dwarfs glow faintly for billions of years before fading into darkness. For larger stars, the ending is more violent. When a massive star runs out of fuel, gravity overwhelms it. The core collapses, and the outer layers explode outward in a supernova. For a brief moment, that single star can outshine an entire galaxy. Supernovas scatter heavy elements, iron, gold, calcium, into space. Those elements later become part of planets, oceans, and even our bodies. The iron in your blood was forged in the heart of a star that died long before the Sun was born. To say that we are made of stardust is not poetry. It is fact. Some stars die even more dramatically. If the collapsing core is heavy enough, it forms a neutron star, a sphere so dense that a teaspoon of it would weigh billions of tons. Neutron stars can spin hundreds of times per second, flashing beams of energy like cosmic lighthouses. And if the star is even more massive, its core collapses into a black hole, a place where gravity is so strong that not even light can escape. Yet even these darkest of objects tell us something profound about the cycle of stars. Endings are also beginnings. The deaths of stars seed galaxies with the materials for new stars, new planets, and perhaps new life. Stars also live in communities. Many form in clusters bound by gravity, shining together for millions of years. Some stars live in pairs, orbiting each other in a delicate dance. Others drift alone, like our Sun, carrying with them their retinues of planets, moons, and comets. The closest star to us beyond the Sun is Proxima Centauri, just over 4 light-years away. That distance may sound small on a cosmic scale, yet with our fastest spacecraft, it would take more than 70,000 years to reach it. The nearest stars are impossibly far, but their light arrives each night, a constant reminder of the vastness around us. Stars have inspired humanity for as long as we have looked upward. Ancient civilizations charted them into constellations, weaving myths and stories into the night sky. Sailors navigated oceans by their patterns. Farmers planted and harvested by their rising and setting. And scientists, studying their light, discovered the laws of physics that govern the universe. Yet despite all we know, stars remain sources of wonder. They flicker with mystery, reminding us of how small and precious our lives are against the backdrop of eternity. And though they burn with unimaginable power, there is something calming in their constancy. Night after night, they shine above us, steady and patient, even as civilizations rise and fall. So the next time you see the stars, remember you are looking at furnaces that create life's elements, at suns that live for billions of years, at explosions that light up galaxies. You are looking at the universe itself in its most beautiful and enduring form. Stars are not just points of light. They are the very engines of creation. As we leave the stars behind, our journey continues outward to worlds orbiting them. In the next section, we will explore exoplanets, strange, diverse, and breathtakingly alien places that expand our imagination of what worlds can be. Exoplanets and alien worlds. For most of human history, we only knew of the planets circling our own sun: Mercury, Venus, Earth, Mars, and the distant giants, Jupiter, Saturn, Uranus, and Neptune. Beyond them lay only imagination, visions of other worlds, other skies, other possibilities. But in the last few decades, a quiet revolution has taken place. Astronomers have begun to find planets around distant stars. These are called exoplanets, and their discovery has transformed our understanding of the universe. The first confirmed exoplanet was found in the early 1990s, orbiting a pulsar, a dead, spinning star. It was an astonishing discovery because it showed that planets could form or survive even around stars that had died in violent explosions. Soon after, astronomers found planets around normal stars, and the list has grown ever since. Today, we know of more than 5,000 confirmed exoplanets, with thousands more waiting to be verified. And this is just the beginning. The universe likely holds trillions of planets, far more than stars. Exoplanets come in astonishing variety. Some are hot Jupiters, giant gas planets that orbit so close to their stars that a single year lasts only a few days. Their skies may be filled with clouds of metal vapor, and their surfaces scorched to thousands of degrees. Others are super-Earths, rocky planets larger than our own, with gravity that would weigh you down and landscapes that may stretch far beyond imagination. Some may be covered entirely in oceans, endless blue worlds with no land at all. Others may be barren deserts blasted by radiation or locked in perpetual twilight. One of the most intriguing kinds of exoplanets is the Earth-like world. These are planets in the habitable zone, the region around a star where temperatures might allow liquid water to exist. Astronomers have already found dozens of such candidates. Kepler 452b, sometimes called Earth's cousin, is one example. It orbits a star similar to our Sun, and though it is larger and heavier than Earth, it may have conditions not entirely unlike our own. Another system, TRAPPIST-1, holds 7 Earth-sized planets, 3 of which lie in the habitable zone. To imagine standing on one of those worlds, looking up and seeing 6 other Earth-sized planets hanging in the sky, is to imagine a view stranger and more beautiful than anything we've ever seen. The methods used to discover these worlds are as ingenious as they are subtle. One technique is the transit method. When a planet passes in front of its star, it blocks a tiny fraction of the starlight. From Earth, the star's brightness dips ever so slightly, and from this dimming, scientists can infer the planet's size, orbit, and sometimes even the composition of its atmosphere. Another method is the radial velocity technique, which detects the wobble of a star as a planet's gravity tugs on it. With these tools, astronomers are peering into the dark and slowly revealing a universe filled with worlds. Exoplanet atmospheres are a frontier of discovery. By studying starlight filtered through a planet's air, scientists can detect gases like water vapor, methane, and carbon dioxide. These molecules are not proof of life, but they are clues, hints that a planet may be active, dynamic, or even habitable. The James Webb Space Telescope has already begun analyzing the atmospheres of distant worlds, bringing us closer to the day when we might find the fingerprints of biology on another planet. Imagine reading the air of a world hundreds of light years away, learning its chemistry as though you were breathing it yourself. Not all exoplanets are gentle or familiar. Some orbit so close to their stars that they are tidally locked, with one side scorched by endless daylight and the other frozen in perpetual night. Others race around their stars in hours, whipped by gravity into dizzying speeds. A few drift alone in the darkness, rogue planets kicked free from their stars, wandering endlessly through interstellar space. The sheer diversity of these worlds reminds us that our solar system, with its stable orbits and friendly conditions, is not the only possible arrangement. The universe allows for endless variations. The search for life drives much of this exploration. If life exists elsewhere, exoplanets are where we are most likely to find it. Worlds with oceans, atmospheres, and energy sources could harbor biology, even if it is only microbial, hidden beneath the waves or in the soil. And if life is out there, then perhaps intelligence too might exist on some faraway planet, looking back at their own night sky and wondering if they are alone. The possibility that both we and they might be gazing outward at the same time is both humbling and thrilling. But even if we never find life, the discovery of exoplanets is already one of the greatest achievements of science. It has shown us that planets are not rare. They are common, perhaps even inevitable, wherever stars are born. And among them, somewhere, may be another Earth, waiting, patient, circling a distant sun. Exoplanets expand our imagination. They remind us that the universe is not limited to what we see each night. It is full of worlds, countless and diverse, each with its own story, its own sky, its own mysteries. In the calm of night, as you drift toward rest, you can picture yourself standing on one of those alien shores under a sky of unfamiliar constellations, knowing that you are still connected to the same cosmos. As we leave the exoplanets, we turn now to one of the most fascinating subjects of all, black holes. In the next section, we will journey into the darkness where space and time themselves bend, and where the universe keeps some of its most profound secrets. Black holes and the mysteries of gravity. That picture of the black hole in Galaxy M87 was more than just an image. It was a doorway into the invisible, proof that what had once been only equations on chalkboards truly exists out there in the cosmos. Later, in 2022, the Event Horizon Telescope revealed Sagittarius A6 itself, our own galactic heart. Though blurry, the sight carried weight. The first look at the dark center around which all of us orbit. Imagine the stillness of that truth, our home galaxy anchored by something we cannot see, yet something we all revolve around. Black holes come in many sizes. Stellar mass black holes form from collapsing stars and weigh a few times more than the Sun. Then there are intermediate black holes, rare and elusive, with hundreds or thousands of solar masses. And at the top of the scale, supermassive black holes dominate galaxy cores, weighing millions to billions of suns. Scientists believe nearly every large galaxy harbors one. They are like the silent architects of the universe, guiding the formation and evolution of galaxies over billions of years. Without them, the night sky might not look the same at all. One fascinating aspect of black holes is time itself. Near the event horizon, time runs differently. Einstein's theory of relativity shows us that gravity bends not only space, but also the flow of time. To a distant observer, a clock near a black hole would tick more slowly. For the traveler who falls in, time would seem normal to them, but from the outside they would appear frozen, forever hanging at the edge. This phenomenon, called time dilation, reminds us how flexible reality becomes under extreme conditions. What feels ordinary to one observer can seem infinite to another. Hawking radiation, another strange prediction, suggests that black holes are not truly eternal. According to Stephen Hawking, quantum effects allow them to slowly leak energy, particle by particle, across unimaginable time spans. The smallest black holes could eventually evaporate, vanishing in a final burst of energy. If true, it means black holes are not permanent prisons, but transient features of the universe. Although they last far longer than stars, planets, or life itself. Black holes also teach us humility. They reveal where our understanding breaks down. Inside them lies the singularity, a point of infinite density where space and time collapse. Our laws of physics cannot yet describe it. Some believe a future theory of quantum gravity will explain what really happens there. For now, the singularity is a mystery, a reminder that even with all our knowledge, there are places the universe still keeps secret. Beyond the science, black holes capture the imagination. Writers and dreamers envision them as gateways to other universes, as engines of cosmic travel, or as metaphors for transformation. Though we cannot yet say whether such visions have truth, the metaphor itself is powerful. A black hole is both an end and a beginning, the death of a star, but also the seed of galactic structure. In their quiet hunger, they shape everything around them, unseen yet essential. And so black holes are not monsters lurking in space, but deep wells of gravity that help define the universe itself. They remind us that the cosmos is full of extremes, from blazing stars to silent voids, and that even in darkness, there is beauty. As we drift onward in this journey, let the thought of these mysterious giants soothe you. Imagine their quiet pull, their patient shaping of galaxies, their timeless presence at the heart of creation. They are both science and poetry, a whisper from the universe that not everything can be seen, but everything leaves its mark. The wonders of stars and stellar life cycle. When we look up at the night sky, what we see are not just distant points of light. We are looking at living things in the cosmic sense, stars, each with a story, a life, a beginning, and an end. Though they appear still and eternal to us, stars are in constant motion, evolving across spans of time so vast we can barely imagine them. Their life cycles are among the most beautiful stories science has uncovered, stories of birth, change, and eventual transformation. Every star begins in a nursery, a vast cloud of gas and dust called a nebula. These clouds drift across galaxies, sometimes stretching for hundreds of light years. Within them, gravity begins its quiet work, pulling matter together until clumps form. As the gas condenses, pressure rises, and deep within the core, temperatures soar to millions of degrees. When hydrogen atoms begin fusing into helium, releasing enormous amounts of energy, a star is born. From that moment, light and heat radiate into the universe, and the long stellar journey begins. Our own sun is a typical star, a yellow dwarf, quietly fusing hydrogen into helium in its core. It has burned steadily for about 4.6 billion years and is expected to continue for another 5 billion. This steady phase of life is called the main sequence, and it is where stars spend most of their existence. In this stage, balance is everything. Gravity pulls inward, while the heat and energy from fusion push outward. Together they hold the star in equilibrium, creating the gentle stability we rely on here on Earth. But stars are not all the same. Some are tiny red dwarfs, much smaller and cooler than the Sun. They burn their fuel so slowly that they can live for trillions of years, far longer than the universe has yet existed. Others are blue giants, massive and blazing, shining fiercely but living short lives, only a few million years before they collapse. The size of a star determines its fate. Small stars fade quietly, while massive stars explode in brilliance. When a star like the Sun runs out of hydrogen, it changes dramatically. The core contracts, heating up, while the outer layers expand outward. The star becomes a red giant, enormous and luminous. Our Sun will one day swell so large that it may engulf Mercury and Venus, leaving Earth scorched. In time, it will shed its outer layers into space, creating a glowing shell called a planetary nebula, while its core shrinks into a white dwarf. These white dwarfs, about the size of Earth but with the mass of a star, glow faintly for billions of years, slowly cooling until they fade into darkness. For massive stars, the ending is far more violent. After burning through hydrogen, helium, and heavier elements, the core collapses catastrophically. In a single moment, the outer layers are blasted away in a supernova, one of the most powerful explosions in the universe. For a brief time, a supernova can outshine an entire galaxy, spreading heavy elements, gold, silver, uranium, and others, into space. These are the elements that form planets, oceans, and even our bodies. In a sense, we are all born from the remnants of ancient stars. Sometimes what remains after a supernova is even stranger. If the collapsed core is heavy enough, it becomes a neutron star, an object so dense that a teaspoon of its material would weigh billions of tons. These stars can spin at incredible speeds, flashing beams of light like cosmic lighthouses. If the core is even more massive, the collapse continues beyond neutron matter, forming a black hole, the ultimate endpoint for the heaviest stars. The diversity of stars is astonishing. Some live as long as galaxies, others die in fiery brilliance. Some are solitary, like our Sun, while many live in pairs or even clusters, bound together in gravitational dances. Globular clusters hold hundreds of thousands of stars packed tightly into a sphere, glittering like jewels in the sky. Open clusters, like the Pleiades, are looser families of young stars, still fresh from their nebula. These gatherings remind us that stars, too, have communities not unlike us. Even more enchanting are variable stars, those that change in brightness over time. Some pulse rhythmically, swelling and dimming as if they were breathing. Others erupt in sudden outbursts, reminding us that stars are not static, but restless, alive with activity. These variations allow astronomers to measure distances across the universe, using the regular heartbeat of certain stars as cosmic rulers. When you gaze at the night sky, remember that every star you see is part of a larger story. Some of the light reaching you tonight began its journey thousands of years ago. In some cases, the star that sent it may already be gone, its life completed, but its final light still crossing space to find your eyes. There is something profoundly calming in that idea, that we are always receiving messages from the past, gentle whispers of stellar lives long concluded. Stars are both ordinary and extraordinary. They are simple furnaces of fusion, yet they create all the building blocks of life. They are distant and unreachable, yet they shape every aspect of our existence. Without them, there would be no earth, no oceans, no breath of air, no spark of consciousness. To understand stars is to understand ourselves, for in a very literal sense, we are their children, stardust given form. As you rest with this thought, imagine yourself lying beneath a clear night sky. Picture each star as a living being, slowly changing, glowing, and giving. Some young, some ancient, some gone but still speaking through their light. It is a reminder of how vast time is and how much beauty unfolds quietly, patiently, far beyond us. Galaxies, islands of stars. If stars are the individual lights of the universe, then galaxies are the great cities that gather them. Each galaxy contains billions, sometimes even trillions of stars, along with clouds of gas, dust, and mysterious dark matter. To look at a galaxy is to look at an island of light adrift in the cosmic ocean, vast and yet graceful. Our own home is the Milky Way galaxy. From Earth, we see it as a hazy band stretching across the night sky, a river of stars too numerous to count. For centuries, humans wondered what it was. Only in the last 100 years did we discover its true nature. Not a local feature of the sky, but an immense spiral of hundreds of billions of stars, stretching more than 100,000 light-years across. And astonishingly, the Milky Way is just one among an unthinkable number, likely more than 2 trillion galaxies in the observable universe. Galaxies come in many shapes. The most familiar are spiral galaxies, like the Milky Way and the Andromeda Galaxy. Their sweeping arms coil outward from a bright central bulge, like pinwheels of light. These arms are nurseries of creation, filled with clouds of gas where stars are born. Some galaxies are elliptical, smooth and rounded, with little structure but enormous mass. Others are irregular, twisted into odd shapes by past collisions. In truth, no two galaxies are alike. Each one is a unique arrangement of light and matter. The Andromeda Galaxy is our nearest large neighbor, about 2.5 million light-years away. Though distant, it is visible to the naked eye from dark skies, appearing as a faint smudge. What's extraordinary is that Andromeda and the Milky Way are moving toward each other. In about 4 billion years, the two will collide, but this will not be the kind of collision we usually imagine. Stars are so far apart that very few will actually hit each other. Instead, gravity will blend the two galaxies into a single, larger structure, a giant elliptical galaxy, sometimes called Milkomeda. In that slow, graceful dance, the night sky will blaze with new patterns of stars. Galaxies are not isolated. They gather in groups and clusters bound together by gravity. Our Milky Way belongs to the local group, a collection of more than 50 galaxies, including Andromeda and many smaller companions. Beyond that lies the Virgo cluster, a massive gathering of thousands of galaxies. And farther still, galaxies are woven into superclusters, forming a vast cosmic web. Seen on the largest scales, the universe looks like a delicate lacework, bright threads of galaxies connected across unimaginable distances, with dark voids in between. Some galaxies are calm, quietly turning and forming stars. Others are active, their centers blazing with power. At the heart of most galaxies, astronomers believe, lies a supermassive black hole. In some, this black hole is feeding, devouring matter, and releasing jets of energy that can outshine the entire galaxy itself. These are called quasars, and though they are billions of light-years away, we can still see their brilliance, lighthouses from the early universe. Galaxies also preserve the history of cosmic time. The light from distant galaxies has traveled for billions of years to reach us. To look at them is to look into the past. The Hubble Space Telescope once pointed at a seemingly empty patch of sky for days and revealed thousands of faint galaxies, each one a story from billions of years ago. That image, the Hubble Deep Field, changed our sense of scale forever. It told us that even the smallest, darkest corners of the sky are teeming with galaxies. The diversity among galaxies is endless. Some are dwarf galaxies containing only a few million stars. Others are giants with trillions. Some are rich in gas and dust, bursting with star formation. Others are ancient and quiet, their stars old and red. Some galaxies are distorted by collisions, stretched into long streams called tidal tails. In every direction, they remind us that the universe is restless, always moving, always reshaping itself. Our galaxy, too, is alive with activity. New stars are forming in its spiral arms, even as others die. Globular clusters orbit like ancient guardians, while dark matter, unseen but powerful, holds everything together. The Milky Way is not a static backdrop. It is a dynamic, evolving world of its own, a home that has nurtured life on one of its countless planets. To imagine galaxies is to imagine the scale of existence. A single beam of starlight from Andromeda began its journey long before humans walked the Earth. When you look at it through a telescope, you are looking into a time when our ancestors were just beginning to dream of fire and language. The universe carries memories, and galaxies are its storytellers. As you think of galaxies tonight, imagine yourself adrift among them, moving through the cosmic web. Picture the spirals glowing, the elliptical giants humming with ancient stars, the irregular galaxies dancing from collisions long ago. Let that vastness comfort you. For though the universe is immeasurably large, we are part of it, made of its dust, living in one of its countless galaxies, sharing its quiet rhythm. Time, relativity, and the nature of reality. Time is one of the most mysterious forces we experience. We live by its ticking, measure our lives in its passing, and yet we understand so little about what it really is. For us, time seems simple. It moves forward, steady and unstoppable. But in the universe, time is far more flexible and strange. Albert Einstein's theory of relativity revealed that time is not an absolute backdrop against which events unfold. Instead, it is woven together with space into a single fabric, space-time. This fabric bends and stretches under the influence of gravity. When a massive object like a star or a planet is present, it distorts space-time around it. And when space-time bends, so does time itself. This means that time does not tick the same everywhere. Imagine two clocks, one on the ground, the other on a mountain top. The one closer to Earth's center, where gravity is stronger, runs slightly slower. The difference is tiny but measurable. In fact, modern GPS satellites must correct for this effect to give us accurate navigation. Without accounting for relativity, your phone's map could be off by miles. The idea becomes even more dramatic near extremely dense objects. Around a black hole, time slows so much that an hour near the event horizon could equal years far away. This concept was beautifully illustrated in the film Interstellar, but it is not fiction, it is a direct prediction of Einstein's equations. Time itself can dilate, stretching and bending depending on where you are and how fast you move. Speed also changes time. The faster you move, the slower your time passes compared to someone at rest. Astronauts aboard the International Space Station actually age slightly less than people on Earth because of their speed in orbit. The difference is only fractions of a second, but it proves that time is not universal. It is personal, shaped by motion and gravity. Some physicists believe that time itself may have begun with the Big Bang. Before that, there may have been no before. The universe's birth was also the birth of time. If that's true, then asking what happened before the Big Bang may be meaningless. Like asking what's north of the North Pole, it is a limit to our intuition, a boundary where familiar ideas break down, and yet time is deeply tied to the arrow of life. We experience it only in one direction, forward. Broken glass does not reassemble and we grow older, never younger. This arrow of time is linked to entropy, the gradual increase of disorder in the universe. Entropy is why heat spreads, why systems decay, why the future feels different from the past. It is a fundamental rhythm guiding the unfolding of events, but some theories suggest that time might not be fundamental at all. It could be an emergent property, a byproduct of deeper rules we do not yet understand. In some quantum models, time disappears altogether, replaced by timeless equations where events simply exist, without a past or future. To us, that feels impossible, but nature often ignores our feelings. Consider time on a cosmic scale. The universe is 13.8 billion years old. Compared to that, a human life is shorter than a blink. Yet within that blink, we can wonder about eternity. The stars overhead are time machines, their light carrying messages from the past. When you look at the Andromeda Galaxy, you see it as it was 2.5 million years ago. When you look at the faintest galaxies, you see them as they were billions of years ago. Their light finally reaching us after traveling almost the age of the universe itself. In a way, the night sky is a museum of time. Every star is a story from the past. Some of the starlight you see tonight began its journey before humans existed, before continents drifted to their present shapes, before ice ages came and went. To look up is to look backward, to remember that time is not only something we live, it is something we can witness across the cosmos. Time also plays tricks with perception. For example, on Earth, our days are not constant. They slowly change as the planet's rotation shifts. 1 billion years ago, a day was only about 18 hours long. In the far future, it will lengthen even more. The Moon is gradually moving away from Earth, and as it does, our rotation slows. The clock we trust so much is itself evolving. And consider this: the universe itself may have an end to time. Some theories predict a heat death when all stars have burned out, all black holes have evaporated, and the cosmos becomes a thin soup of particles drifting in silence. In such a future, time might lose meaning. Nothing new would happen, and the arrow of time could fade into stillness. Yet here we are in the middle of time's great unfolding, able to experience its flow. We live in a moment balanced between the deep past and an unimaginable future. For us, time is the thread that holds memory and hope together. Without it, there would be no story, no growth, no life. As you think about time tonight, let yourself feel its paradox. It is both fleeting and eternal. It shapes us and yet eludes our understanding. You are living in a river that began at the dawn of the cosmos and will continue long after we are gone. To feel that river is to feel part of the universe itself, flowing quietly through the ages. The moon and its hidden mysteries. The moon is our closest neighbor in space, yet it holds a presence far greater than its size. Hanging in the night sky, it feels eternal, a silent companion that has looked down upon Earth since before life began. But beyond its beauty lies a story filled with mysteries, scientific puzzles, and quiet wonders that continue to surprise us. The moon likely formed billions of years ago, when a Mars-sized body collided with the young Earth. The impact was catastrophic, blasting molten rock into orbit. Over time, this material clumped together, cooling into the sphere we see today. If this is true, then the moon is not just a companion, it is family, born from Earth's own flesh. Every time you look at it, you are seeing a piece of our planet lifted skyward by cosmic violence, now glowing with serenity. The moon shapes our world in ways that are easy to forget. Its gravity pulls at the oceans, creating tides that rise and fall with its passing. These tides are not just poetic, they were critical to the evolution of life. Early organisms may have used the shifting shoreline as a stepping stone from sea to land. Even today, tides govern ecosystems, guiding the lives of countless creatures. Without the moon, Earth would be a very different place, quieter perhaps, but also lonelier. And yet the moon is slowly leaving us. Each year, it drifts about 4 centimeters farther away, the result of a slow transfer of energy from Earth's rotation. Long ago, the moon loomed much larger in the sky. In the distant future, it will appear smaller, its influence on tides weaker. Millions of years from now, total solar eclipses, the breathtaking alignment of sun and moon, will cease because the moon will no longer perfectly cover the sun's face. Even this seemingly eternal sight is temporary, a reminder that nothing in the universe stands still. The moon also records time in its scars. Its surface is littered with craters, some billions of years old. Unlike Earth, which erases history through erosion, weather, and life, the moon has no atmosphere to heal its wounds. Each impact remains etched into its face, a cosmic diary written in stone. When astronauts walked upon its surface, they touched not only dust and rock, but a history stretching back to the earliest days of the solar system. And consider this, the far side of the moon, the side we never see, is utterly different from the one facing Earth. While the near side is dominated by dark lava plains, the far side is rugged, thick with craters. For millennia, humanity could only imagine what it looked like. Only in the 20th century did spacecraft finally reveal its hidden face. It was as though the moon had been keeping a secret, a second personality just out of sight. The moon also plays tricks with perception. To our eyes, it seems larger near the horizon, an illusion that has puzzled observers for centuries. In reality, the moon does not change size, but our minds perceive it differently against the landscape. This quiet trick reminds us that even familiar companions can still surprise us, showing that the mystery of the moon is not only out there, but also within our perception. Our lunar neighbor has influenced culture as deeply as it has shaped tides. Ancient calendars followed its cycles, guiding planting, harvests, and rituals. Myths and stories tied the moon to gods, spirits, and dreams. Even today, its phases mark time in subtle ways, connecting us to traditions as old as humanity. A full moon can make a night feel brighter, stranger, almost magical, and yet it is simply sunlight reflected across space, bouncing off a world that is at once foreign and deeply connected to us. Scientists have discovered that the moon is not entirely dead. Beneath its quiet surface, there are signs of seismic activity, moonquakes that rumble through its crust. They are weaker than Earth's earthquakes, but they remind us that the moon is not a frozen relic. It still shifts, still breathes in its own slow rhythm. Its silence hides an inner life, subtle but enduring. And then there is the human connection. Only 12 people have ever walked on the moon, leaving footprints that remain untouched for over 50 years. The dust beneath them has not been blown away by wind, nor washed by rain. Their prints will remain for millions of years. Those small marks are humanity's first steps into the wider cosmos, preserved like fossils of ambition. When we look at the moon, we are not only seeing a natural world, we are seeing a destination, a promise of journeys yet to come. Perhaps the greatest mystery is why the moon feels so close to us emotionally. Countless people across time have gazed up at it, finding comfort, inspiration, or longing in its glow. Lovers have whispered beneath it, poets have written of it, and travelers have followed it across seas. It's more than rock and dust. It is a mirror of human imagination, a canvas for our dreams. As you reflect tonight, let the moon remind you of both constancy and change. It has guided life for billions of years, yet it too is moving, evolving, drifting away. It carries within it the memory of Earth's violent birth and the promise of future journeys. The next time you see it rise, remember that it is not just a light in the night sky. It is a piece of Earth, a witness to history, and a quiet companion to every life that has ever looked upward in wonder. Rivers. The lifelines of Earth rivers have always been the quiet architects of Earth's story. From the trickle of a hidden spring to the roaring currents of the Amazon, they carry not just water, but history, memory, and life itself. Imagine standing at the edge of a riverbank. The surface may look calm, a mirror of sky and trees, but beneath the surface flows a journey that may have begun in distant mountains, glaciers, or rainfall hundreds of miles away. Each drop of water in that stream has traveled a path far older and grander than we can imagine. Rivers shape the land in ways that seem both gentle and unstoppable. Over centuries, their flowing waters carve canyons deeper than skyscrapers are tall. The Grand Canyon, for instance, was etched by the Colorado River over millions of years. Not by sudden force, but by patient persistence. Every bend in a river, every oxbow lake, every smooth stone on a riverbed is a mark of time's artistry, sculpted in silence. They remind us that change need not be loud to be profound, but rivers are more than sculptors of stone. They are carriers of life. Long before roads and airplanes connected our world, rivers were the first highways. Civilizations blossomed along their shores. The Nile nourished ancient Egypt, offering fertile floodplains that allowed agriculture to flourish in the middle of desert sands. The Indus, the Yangtze, the Tigris, and the Euphrates, each river became a cradle of culture, shaping languages, stories, and trade. Without rivers, human history would be entirely different. Even today, rivers remain lifelines. They supply fresh water for drinking and farming, they generate power, and they connect communities. Yet their gifts extend beyond utility. There is a quiet rhythm in rivers that humans have always found soothing. From the soft murmur of a mountain brook to the thunder of a waterfall, rivers have been our companions in meditation and inspiration. Poets, painters, and wanderers alike have leaned close to the sound of flowing water and felt the world grow still around them. Hidden within rivers are entire worlds of creatures. Some of them, like salmon, travel thousands of miles, leaving the ocean to return upstream to the place of their birth. Others, like freshwater dolphins in the Amazon, are so rare and gentle that their very existence feels like myth. Tiny organisms float unseen in the currents, forming the base of food webs. Fish, birds, and mammals all rely on these flowing waters. To walk along a river is to trace the edge of countless lives bound to its currents. The mysteries of rivers are not only in what we see, but also in what we cannot. Beneath the surface, groundwater moves in secret channels, often feeding rivers invisibly. Some rivers even disappear underground entirely, traveling through caves before emerging again miles away. Others, like the Okavango in Africa, spread into great inland deltas, creating seasonal wetlands that teem with elephants, lions, and birds before vanishing into desert sands. Each river writes its own story, shaped by climate, geology, and time. But rivers also remind us of fragility. They flood, they dry, they shift course. The same floods that nourished ancient fields could also destroy villages overnight. Modern dams and pollution show how human hands can alter rivers, sometimes silencing their natural rhythms. Yet even in these challenges, rivers endure. They find new paths, they cleanse themselves over time, and they continue their eternal flow toward the sea. In their resilience, rivers mirror the persistence of life itself. On a planetary scale, rivers play roles we are only beginning to understand. They transport sediments that create fertile plains, carrying minerals from mountains to oceans. They regulate climate by storing and releasing water in cycles. Even their sounds may have unseen effects, calming minds, lowering heart rates, and easing sleep. Perhaps explaining why so many people drift off peacefully beside the sound of trickling streams. Perhaps the most humbling thought is that rivers do not truly end. When they meet the sea, their waters simply change form, joining tides and currents, evaporating into clouds, and falling again as rain. A river's journey is circular, endless, part of Earth's heartbeat. The water in your glass may once have coursed down an ancient riverbed, carved canyons, and nurtured forests long before humans walked the land. In every river lies continuity, a reminder that all life is connected through the same cycles of flow. So the next time you stand beside a river, whether a narrow stream or a mighty flood, pause and listen. Beneath the flowing sound is a story of mountains crumbling, forests thriving, civilizations rising, and species surviving. The river is not just water. It is memory, journey, and lifeblood, carrying the whispers of earth across the land. The hidden world, beneath soil beneath our feet, lies a world so alive, so complex, that we often forget it exists at all. The soil beneath every forest, field, or garden is not just dirt. It is a living system, filled with hidden networks, ancient minerals, and countless organisms working in silence. To walk across the Earth is to step on one of the most intricate and essential ecosystems ever created. Take a handful of soil, and you are holding a universe. Within that small clump are billions of microorganisms, more than the number of people on our planet. Tiny bacteria, fungi, protozoa, and nematodes weave together in an invisible dance. Many of them are so small that they will never be seen by the naked eye, yet their work shapes the very air we breathe and the food we eat. They recycle dead leaves into nutrients, release gases into the atmosphere, and form partnerships with plants that stretch back hundreds of millions of years. Among the most extraordinary players in this hidden world are fungi. Beneath forests, thin threads of fungal filaments stretch for miles, connecting trees and plants in vast underground webs. Through these connections, trees share sugars, minerals, and even warning signals. A sapling struggling in the shade may receive carbon from an older tree nearby. In return, fungi receive nutrients they cannot produce themselves. This partnership is so essential that some scientists call it the Wood Wide Web, a hidden network humming beneath every step we take. Soil also carries memory. Each layer of earth holds traces of the past. Pollen grains from ancient forests, charcoal from old fires, bones of creatures long gone. Archaeologists can read soil like a diary, uncovering the stories of civilizations that once thrived, as well as climates that shifted across millennia. In some places, preserved soils even hold footprints from thousands of years ago, still intact, marking the paths of people and animals who walked across soft mud long before us. The minerals in soil connect us to Earth's deeper history. Sand, clay, and silt are the fragments of mountains ground down over millions of years. With every storm, rivers carried particles from peaks into valleys, spreading them across plains. Over time, these particles mixed with organic matter, creating the fertile soils that sustain forests, grasslands, and crops. In this way, the roots of every plant are not just touching dirt, they are reaching into the remains of ancient mountains, drinking the memory of stone. In deserts and dry lands, soils tell a different story. Without much organic matter, they shimmer with minerals and salts glowing red, white, or golden under the sun. Yet even here, life persists. Microbes can enter dormant states, waiting years for a drop of rain before reawakening. When storms finally come, the desert floor blooms as seeds that have waited underground for decades burst into flower. Soil, even in the harshest places, is a reservoir of possibility. Human history is inseparable from soil. The earliest farmers depended on fertile river valleys, where nutrient-rich silt from annual floods renewed the land each year. Even today, the food that sustains billions comes from the thin top layer of soil covering the continents. This layer is fragile, often less than a meter deep. Yet without it, fields could not grow grain, orchards could not bear fruit, and forests could not thrive. Soil is the quiet foundation of civilization, carrying on its work unnoticed beneath our feet. Animals, too, depend on soil in hidden ways. Earthworms, tunneling endlessly, aerate the ground and recycle organic matter, making nutrients available to plants. Insects build vast colonies beneath the surface, while burrowing mammals create tunnels that reshape ecosystems. Birds forage for seeds and insects in the soil. Even humans have built shelters and storage pits underground, drawing strength from the steady coolness of the earth. Soil is not an inert surface. It is a living shelter, feeding and protecting countless lives. Scientists studying soil are only beginning to grasp its full complexity. For example, soils store more carbon than all the world's forests and atmosphere combined. This makes them crucial in regulating climate. If soils are degraded, that carbon is released into the air, contributing to warming. If soils are nurtured, they become powerful allies in sustaining balance. In this way, the ground we walk on is not just supporting us physically, it is also helping to sustain the stability of our entire planet. The next time you kneel in a garden or walk barefoot across grass, pause for a moment. Beneath your feet is not just dirt, it is an entire kingdom. A living world, ancient and eternal, filled with unseen dramas of birth, death, cooperation, and survival. The soil holds the bones of the past, the food of the present, and the seeds of the future. It whispers to us, if we listen closely, that life thrives not only in the open air and light, but also in the quiet, hidden depths below. Deserts, stillness and survival. When most people picture a desert, they imagine endless sand dunes shimmering under a blazing sun. Yet deserts are far more varied and mysterious than this single image. They cover nearly a third of Earth's surface and include icy plains in Antarctica, rocky plateaus in Asia, and vast sandy seas in Africa. What unites them is not heat, but dryness. A desert is simply a place where little rain falls, where life must adapt to scarcity, silence, and extremes. The stillness of deserts has a power of its own. Step into one and you quickly notice the absence of familiar sounds. No rustling leaves, no flowing rivers, only wind whispering across stone and sand. This quiet amplifies every detail, so the crunch of your footsteps, the distant call of a bird, the soft hiss of shifting grains. For centuries, travelers have described deserts as places where time feels slower, where the vastness makes human worries seem small. Yet within this apparent emptiness lies resilience. Plants and animals in deserts have evolved astonishing strategies to survive. Cacti, for example, store water in swollen stems, shielded by spines that also reduce evaporation. Desert flowers lie dormant as seeds for years, waiting for a single rainfall to bloom in a sudden explosion of color. Insects burrow deep to escape the heat, while nocturnal mammals emerge only at night when the air cools. Even camels, symbols of desert travel, can endure days without drinking, conserving water in ways no human could match. The Sahara Desert, stretching across northern Africa, is the largest hot desert on Earth. Its dunes can reach heights taller than skyscrapers, shaped endlessly by the winds. Yet even here, life clings on. Small oases scattered across the Sahara support communities of people, date palms and birds. Ancient trade routes once wound through these sands, linking distant civilizations. Beneath the desert floor, hidden aquifers hold water deposited thousands of years ago, sustaining life in one of the harshest environments known. Not all deserts are hot. Antarctica, the coldest place on Earth, is technically the largest desert of all. It receives less precipitation than the Sahara, and much of its snow never melts. Instead, layers of ice and frozen wind create a desert of cold and silence. Life here survives in extremes of a different kind. Penguins huddle together against icy winds. Microscopic organisms endure within frozen lakes sealed beneath miles of ice. Even in the most unforgiving environments, life finds a foothold. Deserts are also places of hidden history. Fossils of ancient rivers and forests are often preserved in their dry climates. The Gobi Desert in Mongolia, for example, has revealed dinosaur eggs perfectly preserved in sand for over 70 million years. The Atacama Desert in Chile, one of the driest places on Earth, is so similar to Mars that scientists test rovers and instruments there before sending them to the Red Planet. Walking across the Atacama feels like walking on another world, where silence is absolute and stars burn brighter than anywhere else. Despite their arid nature, deserts shape weather across the globe. Winds from the Sahara carry dust thousands of miles, fertilizing rainforests in South America with minerals. These dust clouds also influence hurricanes in the Atlantic. The connection is striking. One of the driest places on Earth helping sustain one of the wettest. In this way, deserts remind us that no environment exists in isolation. Each is woven into the planet's greater balance. Human cultures have long been shaped by deserts. Nomadic tribes learned to navigate by stars and survive on limited resources. Ancient civilizations built cities at the edges of deserts, relying on rivers like the Nile or the Tigris for water. The stories, songs, and spiritual traditions born in deserts often emphasize endurance, simplicity, and awe of the vast unknown. Even today, deserts inspire artists, scientists, and travelers who find beauty in their stark landscapes and endless skies. At first glance, deserts may appear lifeless, but pause for a moment. Beneath the sand, seeds wait for rain. Beneath the rocks, animals wait for nightfall. Even in the harshest climates, life holds on with quiet determination. Deserts are reminders that silence does not mean emptiness, and stillness does not mean absence. They are landscapes of patience where survival itself becomes an art. To walk across a desert is to experience two truths at once. On one hand, it feels alien, harsh, and overwhelming in its scale. On the other, it feels eternal, grounding, and strangely peaceful. The horizon stretches endlessly, the stars blaze overhead, and the air is filled with a silence so complete that it feels like listening to the Earth's own heartbeat. In deserts, survival is not about abundance, but about balance. Every drop of water, every patch of shade, every rare rainfall is treasured. This careful equilibrium is what makes deserts so fragile and yet so enduring. They show us that life does not need excess to thrive. It needs only resourcefulness, patience, and an unshakable will to endure. Earth's green cathedrals step into a forest, and you enter a cathedral not built by human hands, but by time, rain, and sunlight. The air feels different here, cooler, heavier with moisture, and filled with the scent of earth and leaves. Light filters down through canopies like stained glass, dappling the forest floor in shifting patterns. Every tree is like a column, every branch an arch, together forming one of Earth's most ancient sanctuaries. Forests are not just collections of trees. They are living, breathing systems that shape the very conditions of life on our planet. Forests cover about a third of Earth's land surface, but their influence extends far beyond their boundaries. They regulate the climate, absorbing carbon dioxide and releasing oxygen. A single mature tree can produce enough oxygen each year for 2 people to breathe. Multiply that by the trillions of trees across the globe, and you begin to understand how forests act as the lungs of our planet. They also regulate rainfall, drawing moisture up from roots and releasing it into the atmosphere, helping to create clouds and storms that water the land far beyond the forest itself. The Amazon rainforest, often called the lungs of the Earth, holds more species than any other place on the planet. In just a few square miles, there may be more kinds of plants and animals than in entire countries elsewhere. Jaguars move silently through undergrowth. Brightly colored macaws wheel above the canopy. Tiny insects crawl across leaves, each playing a role in the vast network of life. Scientists believe that countless species in the Amazon have yet to be discovered, hidden in layers of vegetation so dense that sunlight rarely reaches the ground. But not all forests are tropical. Boreal forests stretching across the northern latitudes of Canada, Russia, and Scandinavia are the largest forest type on Earth. Made up mostly of coniferous trees like spruce, pine, and fir, these forests endure long, harsh winters and short summers. In their silence, they store immense amounts of carbon, locked away in cold soils and dense wood. Without them, our atmosphere would be far less stable. Forests are also timekeepers. Some trees live for thousands of years, bearing silent witness to history. The giant sequoias and redwoods of California tower hundreds of feet into the air and may be older than entire civilizations. In their rings, they carry records of droughts, floods, and fires stretching back millennia. To stand beneath them is to stand in the presence of deep time, life measured not in decades, but in centuries and beyond. Life in forests is not just vertical, but interconnected. Roots, fungi, insects, and animals all create a web of relationships that sustains the whole. Fallen trees become nurseries for new seedlings. Ants clear leaf litter, recycling nutrients. Birds spread seeds, allowing trees to regenerate. Predators keep populations in balance, ensuring that no single species overwhelms the rest. Every part of a forest is linked like organs in a living body. Forests have always been places of human imagination. Ancient myths placed gods, spirits, and magical creatures within their depths. Folktales often begin with a hero venturing into the woods where transformation awaits. Even today, forests feel different from other landscapes, both protective and mysterious, peaceful yet full of hidden life. They remind us of how small we are, but also how connected we are to everything around us. Sadly, forests are also fragile. Human activity has cleared vast areas for farming, logging, and development. Yet even in their fragility, they show resilience. Secondary forests can regrow, and conservation efforts can protect what remains. The songs of birds return, streams run clear again, and seedlings push up through soil when given the chance. This resilience speaks to the patience of nature, a quiet willingness to heal if we allow it. To walk through a forest is to remember that we belong to something larger. Every breath we take is tied to the oxygen produced by leaves. Every rainfall depends on the moisture they release. Every story of life on Earth, from the smallest insect to the greatest whale, is connected to forests in some way. They are not just landscapes. They are guardians, keeping the planet balanced and alive. Forests are Earth's green cathedrals. Their silence is filled with whispers of wind, their height with lessons of endurance, their depth with mysteries still unknown. To stand among them is to feel awe, a reminder that we too are part of this vast, breathing world. Oceans, the planet's blue. Look at Earth from space, and the first thing you see is not land, but water. Vast, endless shades of blue stretch across the globe, interrupted only by scattered continents. Oceans cover more than 70% of Earth's surface, making our planet unique among all known worlds. They are not just bodies of water. They are the heart of Earth itself, pumping life, shaping climate, and holding mysteries deeper than we can yet imagine. The oceans cradle the origins of life. Billions of years ago, long before forests, deserts, or mountains existed, the first living cells stirred in salty seas. Those ancient waters nurtured the beginnings of biology, giving rise to everything from bacteria to fish, and eventually to us. Even today, the chemistry of our blood echoes that of seawater, as if carrying a memory of the place we all began. Oceans are vast reservoirs of energy and motion. Their currents act like conveyor belts, transporting heat around the globe. The Gulf Stream, for example, carries warm water from the tropics across the Atlantic, keeping parts of Europe far warmer than they would otherwise be. Without these currents, many regions of Earth would be locked in ice or scorched by extremes. The ocean quietly balances our climate, a silent force working day and night. The depth of the ocean is almost unfathomable. The Mariana Trench plunges nearly 7 miles into darkness, deeper than Mount Everest is tall. At these depths, pressure is so intense it could crush steel, yet life still exists. Strange fish with glowing bodies drift in the blackness. Entire ecosystems thrive around hydrothermal vents, where superheated water gushes from the seafloor. Here, in places without sunlight, microbes and creatures feed on chemical energy, rewriting our understanding of what life needs to survive. The diversity of life in the ocean is staggering. Coral reefs, often called the rainforests of the sea, host a quarter of all marine species. Fish dart in flashes of color. Sea turtles glide gracefully. Tiny plankton drift in countless numbers, forming the base of food chains that stretch up to whales, the largest animals ever to live. Every drop of ocean water is alive with movement, from the smallest microbes to giant predators. Oceans also connect humanity. For millennia, they have been highways for exploration, trade, and migration. Entire cultures grew from their coasts, drawing food, inspiration, and stories from the sea. Sailors once navigated by stars reflected on dark waves, and fishermen built traditions around the rhythms of tides. Even today, oceans feed billions of people and carry the ships that keep our global world linked. Yet the ocean is not just a provider, it is also a mirror. Its tides respond to the moon's pull, reminding us of the bond between Earth and its companion. Its storms reveal the power of wind and heat, reshaping coasts overnight. Its calm can lull us into peace, while its fury can humble us. Standing at the shore, watching waves roll in, is to feel both comfort and awe. The ocean is also a place of sound. Whales sing songs that travel for hundreds of miles. Waves crash with timeless rhythm. Even in its deepest silence, the sea hums with life, a constant chorus of clicks, rumbles, and whispers. To close your eyes and listen is to hear the planet breathing. For all we know, much remains hidden. Scientists estimate that more than 80% of the ocean has never been mapped or explored. Entire species may live and die in its depths without us ever knowing. In this way, the ocean is both familiar and mysterious, a reminder that even on our home planet, vast realms remain beyond our reach. Oceans are Earth's blue heart. They give us breath, food, and stability. They connect continents, cultures, and creatures in ways both visible and invisible. To imagine Earth without oceans is to imagine a lifeless rock. With them, the planet becomes vibrant, diverse, and alive. The next time you hear the sound of waves or see the horizon blur into water, pause for a moment. Behind that endless blue lies the story of our beginnings, the balance of our present, and the promise of mysteries yet to be discovered. The oceans are not just water. They are the living soul of Earth itself. The atmosphere, Earth's invisible shield surrounding. Earth is a delicate veil of gases we call the atmosphere. From the ground, it feels invisible, but this thin blanket is the difference between a living world and a barren rock. It stretches hundreds of miles upward, growing thinner until it fades into the blackness of space. Yet most of the air, the part that matters most to life, clings close to the surface, a fragile layer only a few miles thick. The atmosphere is a shield, constantly at work. It blocks deadly radiation from the sun, filters harmful ultraviolet light, and burns up countless meteors before they can reach the ground. Without it, Earth would be scarred by craters like the Moon. Each shooting star we see at night is a tiny rock, disintegrating in this invisible armor, a reminder of how protected we truly are. The air is also a reservoir of life. Every breath you take contains oxygen released by plants, much of it from microscopic phytoplankton drifting in the ocean. Nitrogen, the most abundant gas, helps feed crops when captured by soil bacteria. Even carbon dioxide, though often spoken of as a problem, is essential for plants to grow. Our atmosphere is not just air. It is a balanced mixture tuned to sustain life across land and sea. Weather, too, is the work of the atmosphere. The gentle breeze, the rush of storms, the rhythm of rain, all are born from the movement of air and moisture around the globe. Clouds gather, break, and drift in endless formations, painting the sky with ever-changing patterns. Sunlight filters through them at dawn and dusk, scattering into pinks and oranges that make skies glow like fire. Every sunset is a gift of atmosphere, bending and scattering light into beauty. Higher up, the atmosphere divides into layers, each with its own role. The troposphere, where we live, is filled with clouds and weather. The stratosphere holds the ozone layer, our shield against ultraviolet radiation. Above that lies the mesosphere, where meteors flare. Then the thermosphere, glowing with auroras as charged solar particles collide with gases. Finally, the exosphere blends into space, where the last wisps of air escape into the void. Together, these layers form a staircase to the stars. Auroras themselves are one of the atmosphere's greatest wonders. Curtains of green and purple ripple across polar skies, created when solar winds interact with Earth's magnetic field and upper atmosphere. To stand beneath them is to feel the planet alive, glowing with cosmic energy. They are not just spectacles of light. They are living proof of the atmosphere's constant defense against the sun's storms. The atmosphere also carries Earth's voice. Sound travels through it, letting us hear birds, music, laughter, and even the quiet rustle of leaves. On the Moon or Mars, such sounds would vanish into silence, but here the air carries them effortlessly. It makes Earth not only a world of sights, but a world of songs. Yet the atmosphere is fragile. Though it seems endless, pollution, greenhouse gases, and deforestation alter its balance. Climate change is a reminder of how quickly we can shift this delicate system. Still, the atmosphere adapts, absorbing, cycling, and renewing. It is both resilient and vulnerable, a reflection of the life it protects. When astronauts look back at Earth from orbit, they describe the atmosphere as a thin blue line hugging the planet. Seen from space, it looks impossibly delicate, like the skin of a bubble. That fragile glow holds in warmth, nurtures forests and oceans, and cradles every breath we take. The next time you look up at the sky, whether it's filled with clouds, glowing with stars, or blazing with sunset colors, remember what you are seeing is more than air. It is Earth's shield, its painter's brush, its song carrier, and its life giver. A thin, invisible blanket that makes our world the rarest jewel in the cosmos. Forests, Earth's green. Lungs forests are among Earth's most vital treasures, covering about a third of the land. They are more than a collection of trees. They are living systems that breathe, cycle water, store carbon, and shelter countless species. Every forest, whether dense rainforest or sparse boreal woodland, is a cathedral of life. Rainforests like the Amazon are often called the lungs of the planet. With each sunrise, billions of leaves open their tiny pores to drink in carbon dioxide and release oxygen. The scale is unimaginable. The Amazon alone is home to hundreds of billions of trees, each one participating in this planetary respiration. Together they create 1/5 of the oxygen in our atmosphere. To breathe deeply in a forest is to share in that ancient exchange, the quiet rhythm of photosynthesis sustaining life across the globe. Forests are also fountains of water. Through a process called transpiration, trees release vapor into the air, forming clouds that drift and condense into rain. In the Amazon, this cycle is so powerful that the forest generates much of its own rainfall. Without forests, rainfall patterns would collapse, rivers would shrink, and landscapes would dry. A single tree may seem small, but multiply its breadth by millions, and you have the power to shape entire climates. Beneath the soil, forests hide even greater complexity. Tree roots connect with fungi to form vast networks, sometimes called the wood wide web. Through these underground highways, trees exchange nutrients, water, and even signals of distress. A mother tree may send extra carbon to her saplings, or a damaged tree may receive support from its neighbors. Forests in this sense are not simply collections of individuals, but communities woven together by unseen threads of cooperation. The diversity within forests is staggering. Tropical rainforests cover less than 10% of Earth's land, but harbor more than half of all known species. Birds flash in bright colors, insects hum in endless variety, mammals move silently through shadows, and plants compete in dazzling displays of form. Each species plays a role, forming layers of canopy, understory, and forest floor, all balanced in a living web of interdependence. Forests are also libraries of memory. Tree rings record droughts and floods, fire scars and seasons of abundance. Each trunk is a timeline preserving the history of Earth's changing climate. In old-growth forests, some trees have stood for centuries, surviving storms and human history alike. To touch such a tree is to touch time itself, a witness older than entire civilizations. Even forests shaped by fire tell stories of resilience. In pine forests, flames are not always destructive. They can be part of renewal. Some cones only open when scorched, releasing seeds into fertile ash. The forest regrows stronger, adapted to cycles of destruction and rebirth. This capacity to turn loss into renewal is one of nature's most profound lessons. Forests are more than ecosystems, they are companions to humanity. They have given us food, shelter, medicine, and inspiration since our beginnings. Ancient cultures told stories of sacred groves, spirits dwelling among trees, and wisdom whispered in leaves. Even today, the hush of a forest brings peace. Scientific studies confirm what many instinctively feel. Time spent among trees lowers stress, heals the mind, and strengthens the heart. Forests, quite literally, make us healthier, but forests are also vulnerable. Deforestation, logging, and climate change threaten their existence. The loss is not only ecological but deeply human, erasing biodiversity, displacing communities, and releasing stored carbon into the air. Yet forests remain resilient. With care, protection, and replanting, they can return. Seeds carried by wind or birds sprout in abandoned fields, and in decades, new woodlands rise where none stood before. Life waits patiently for its chance to grow again. When seen from above, a forest canopy looks like an endless sea of green rolling across hills and valleys. From within, each tree feels monumental, a tower of wood and leaf stretching toward the sky. Together, they form one of Earth's most magnificent expressions of life: lungs that breathe, hearts that beat, and voices that whisper through rustling leaves. The next time you walk through a forest, pause and listen. Feel the coolness in the air, notice the filtered light, and hear the quiet hum of hidden creatures. What surrounds you is not just scenery, but a living organism stretching miles and centuries, bound together in patience and resilience. Forests are Earth's green lungs, exhaling life with every breath of wind. Rivers. Earth's arteries of life. Rivers are the Earth's moving veins, carrying life across landscapes. They begin as tiny trickles in mountain springs fed by melting snow or hidden groundwater. Those small beginnings join and grow, winding their way through valleys, carving cliffs, and eventually reaching the vast embrace of the sea. From source to mouth, rivers tell the story of connection, of how water links distant places into a single flowing system. The power of rivers lies not only in their beauty, but in their persistence. Over millennia, rivers cut through stone, shaping canyons and gorges of astonishing depth. The Grand Canyon, for example, was carved by the patient work of the Colorado River, its waters slowly wearing through layers of rock to reveal 2 billion years of Earth's history. In these immense walls, we see time written in stone, and in the river at the bottom, the tireless sculptor, still at work. Rivers nurture life wherever they go. Along their banks, lush ecosystems form. Willows and reeds sway in the current, fish dart through shallow pools, birds gather to feed, and mammals come to drink. Entire civilizations have flourished beside rivers. The Nile, Tigris, Euphrates, Indus, and Yangtze gave rise to ancient societies that depended on their floods to enrich the soil. Without rivers, human history would look very different. They are more than waterways. They are cradles of culture. The sounds of rivers carry their own music. A gentle stream murmurs as it slips over stones. A waterfall roars with force, shaking the ground. Together they create a symphony that has soothed humans since the beginning. To sit by a river is to hear the heartbeat of the land, steady and eternal. But rivers are not only pathways for water. They are corridors for travel and exchange. For centuries, they served as the first highways carrying boats, trade, and ideas between communities. Even today, rivers remain vital channels of connection, linking villages, cities, and countries through their winding routes. Underground, rivers flow in secret. In caves, hidden streams carve chambers and tunnels unseen by most eyes. In deserts, rivers sometimes vanish into sand only to reappear far away, resurfacing in oases that offer life where none seems possible. These mysteries remind us that rivers are not always visible, yet their influence shapes landscapes in ways both subtle and grand. The creatures that live within rivers are as varied as the waters themselves. From freshwater dolphins of the Amazon to salmon that journey from the ocean back upstream to spawn, rivers are highways of migration and survival. Insects dance on the surface, amphibians thrive along muddy banks, and entire food webs revolve around the movement of flowing water. Without rivers, the diversity of life would be immeasurably poorer. Rivers also embody change. No two moments are ever the same. A river you see today is not the one you saw yesterday. New water has flowed, new sediments shifted, new currents formed. This ceaseless transformation teaches us about impermanence and renewal. To watch a river is to witness time moving in liquid form. Yet, like forests, rivers face challenges. Pollution, damming, and climate change threaten their health. When rivers are blocked or drained, ecosystems falter, and communities lose their lifelines. But restoration is possible. When dams are removed and floodplains restored, fish return, wetlands revive, and the waters flow free again. The resilience of rivers mirrors the resilience of life itself. Given the chance, they heal. Standing by a river, one can feel both small and deeply connected. The water flowing past has been part of countless cycles. Perhaps it once fell as rain on distant mountains, flowed through glaciers, or swirled in ancient seas. Now it passes by you on its way to another place, another time. Rivers remind us that we too are part of this grand circulation, carried along by forces older than memory. To walk beside a river is to walk beside history, nature, and time itself. Their currents have shaped continents, nourished civilizations, and inspired songs and stories for as long as humans have watched water move. Rivers are Earth's arteries of life, flowing ceaselessly, carrying not only water, but connection, memory, and hope. Islands, worlds within. Worlds scattered across Earth's oceans lie islands, each one a world of its own. Some are tiny dots of sand barely large enough to hold a single palm tree. Others are vast landmasses like Greenland or Madagascar, containing entire ecosystems found nowhere else on the planet. What all islands share is their sense of separation, places where isolation shapes life in strange and wondrous ways. Volcanic islands rise from fire. Deep beneath the sea, magma erupts through cracks in the crust, cooling into rock that slowly builds above the waterline. This is how the Hawaiian Islands were born, one fiery eruption at a time. Over centuries, bare black lava becomes cloaked in green as seeds arrive on the wind, carried by birds, or even floating across the ocean. Life takes root in silence, and from the flames of Earth, a paradise emerges. Other islands are carved by ice and water. Rising seas isolate mountaintops or plateaus, turning them into new worlds cut off from the continents. River deltas splinter into maze-like networks, forming countless islets where birds and fish thrive. Even corals, tiny animals, build enormous reef islands, creating lagoons and beaches that shelter communities of life above and below the waves. Because they are isolated, islands often become laboratories of evolution. On the Galapagos, finches adapted their beaks to different food sources, a discovery that inspired Charles Darwin's theory of natural selection. In Madagascar, lemurs evolved into dozens of species found nowhere else on Earth. On New Zealand, birds took to the skies and forests in unusual ways, some losing the power of flight altogether. Islands remind us that separation breeds creativity, and that life, when left alone, invents endlessly new forms. Islands also shape human culture. For some, they are homelands filled with traditions passed down through generations. For others, they are symbols of refuge, places of retreat and solitude. Myths and legends often place enchanted lands on faraway islands, where the boundary between the real and the magical blurs. Even today, to arrive on an island feels like entering another world, distinct from the mainland and full of its own rhythms. The seas around islands are as important as the land itself. Coral reefs, mangroves, and seagrass meadows form protective barriers, nurturing fish and absorbing the energy of storms. These ecosystems support millions of people who rely on them for food, shelter, and protection. Islands may seem small compared to continents, but they hold outsized importance, anchoring both biodiversity and human survival. Islands also face unique challenges. Rising seas, stronger storms, and human pressures threaten their fragile balance. Some small islands are already disappearing beneath rising oceans, their beaches eroding into memory. For the people who live there, this isn't just environmental loss, but cultural loss, the vanishing of home. And yet resilience shines through. Communities adapt, ecosystems rebuild, and islands endure in ways that reflect the strength of both nature and human spirit. What makes islands truly enchanting is their sense of mystery. Surrounded by water, they feel like hidden worlds, each holding stories written in stone, sand, and forest. They teach us about isolation, adaptation, and the delicate threads that connect life across vast distances. To stand on an island shore and gaze out at the horizon is to feel both separated and connected at once. The ocean stretches endlessly, yet every wave is a bridge to another land, another story. Islands are worlds within worlds, reminders that even the smallest patch of Earth can hold wonders as deep as the sea itself. Oceans, the blue heart of Earth. If Earth has a heartbeat, it is the ocean. Covering more than 70% of the planet's surface, the oceans are the cradle of life, the regulator of climate, and the great unifying force that connects every shore. When we look at Earth from space, it glows blue, not green or brown, because water defines us more than land ever could. The oceans are not empty. They are living, breathing worlds, as vast and intricate as the continents above them. The ocean is ancient, older than mountains and forests. Billions of years ago, it was here that life first stirred, fragile strands of molecules that would eventually give rise to everything we know. Even now, the ocean teems with microscopic plankton that sustain the very fabric of life on Earth. These tiny drifters produce much of the oxygen we breathe, filling the air with every gentle ripple and every wave that rises under the sun. Without them, there would be no forests, no animals, no us. Its depths remain largely unexplored, a mystery greater than outer space. We have mapped the surfaces of distant planets more thoroughly than the ocean floor beneath our own feet. In the crushing blackness of the deep, strange creatures drift and flicker with their own light. Some fish glow like lanterns, others bear jaws full of needle teeth, and some seem more like dreams than living beings. Each dive into these depths reveals new forms of life, reminding us that Earth is still full of secrets waiting to be uncovered. The ocean also shapes the world we live in every day. It is the engine of weather, moving heat and moisture across the globe. The warm waters of the tropics give rise to hurricanes, while cold currents regulate climates thousands of miles away. Coastal breezes, monsoon rains, and even the patterns of drought and snow are tied to the shifting moods of the sea. To understand the ocean is to understand the rhythms of the Earth itself, and yet the ocean is not only powerful, it is soothing. Its waves move with a rhythm that mirrors our own breathing, steady and timeless. To sit by the shore and listen to the surf is to feel connected to something immense, yet comforting. Cultures around the world have long held the sea as sacred, a source of myth, song, and imagination. It represents both danger and refuge, both endless possibility and unfathomable depth. The ocean is also a realm of incredible partnerships. Coral reefs, though covering less than 1% of the ocean floor, host a quarter of all marine species. Here, fish flash with colors brighter than jewels, sea turtles glide gracefully, and sharks patrol with ancient patience. Mangrove forests stand where sea and land meet, protecting coastlines and nurturing young creatures in their roots. Kelp forests rise like underwater cathedrals, swaying with currents while sheltering entire communities of life. Each ecosystem is delicate yet vital, woven together by relationships both visible and hidden. But like islands, oceans too face challenges. Plastic waste drifts in gyres, forming floating scars. Overfishing strains populations that once seemed endless. Rising temperatures bleach coral reefs and push marine life beyond their limits. The ocean, vast as it is not invulnerable. Still, there is hope. Conservation efforts, marine protected areas, and the resilience of life itself give us reasons to believe in recovery. After all, the ocean has endured for billions of years, adapting and reshaping itself through countless changes. Perhaps the most humbling truth is this: no matter how far we live from its shores, the ocean is part of us. Our bodies carry salt water in our veins, echoes of the seas from which our ancestors emerged. Each breath we take is a gift from ocean plankton. Each storm and cloud carries the ocean's touch. To ignore it is to ignore our own origins. So when we think of Earth, we must think of the ocean, not as a separate world, but as the heart of this one. Its tides mark time. Its depths hold mysteries. Its waves connect us all. To stand at the water's edge is to stand before the vastness of life itself, a reminder that we are small, yet part of something immeasurably grand. Deserts. The silent kingdoms of sandy forests are the lungs of the planet, and oceans are its heart. Deserts might be the Earth's great meditative spaces, vast, quiet, and timeless. At first glance, they seem empty, an endless stretch of sand or stone where little can survive. Yet the truth is far richer. Deserts are alive, filled with hidden rhythms and secret adaptations that make them some of the most astonishing landscapes on Earth. A desert is not just defined by heat. What truly defines it is dryness. Rainfall is scarce, sometimes less than a few inches a year, and often arriving in sudden bursts rather than gentle showers. In the Atacama Desert of Chile, rain may not fall for decades. And yet, in such parched conditions, life persists. Delicate mosses hiding in shaded cracks, cacti swelling with water like living reservoirs, and foxes and birds that make the most of every drop. Deserts prove that scarcity does not mean emptiness. It means resilience. Sand dunes are among the most iconic desert features. These mountains of shifting grains seem to move like waves, sculpted by the wind into ever-changing forms. Some dunes can grow taller than skyscrapers, and their crests sing when the wind pushes sand down their slopes, creating low, haunting vibrations known as singing sands. To stand among them is to realize that deserts are not still. They breathe, shift, and whisper across the centuries. Deserts are also places of extremes. By day, the sun scorches the ground, with temperatures climbing to levels that can blister skin in minutes. By night, the heat escapes into the open sky, and temperatures plummet, sometimes near freezing. To survive such swings, animals and plants have developed ingenious strategies. Fennec foxes with their enormous ears radiate excess heat. Desert beetles collect morning dew on their backs, funneling water to their mouths. Seeds remain dormant for years, waiting for the rare rainfall that will trigger a sudden, breathtaking bloom of wildflowers, painting the desert in waves of color for just a few days. One of the greatest deserts, the Sahara, is larger than the continental United States. Yet thousands of years ago it was not sand at all, but a green savanna filled with lakes, animals, and human settlements. Ancient rock carvings still showed giraffes, elephants, and people who once thrived where today only dunes remain. Deserts remind us that landscapes shift over time, that nothing is permanent. They are snapshots in Earth's vast story. Not all deserts are hot. The largest desert in the world is actually Antarctica, where snowfall is rare and icy winds sweep across barren expanses. The Arctic, too, is classified as a desert. These polar deserts reveal that deserts are not about heat, but about dryness. They hold secrets locked in ice, fossils buried beneath snow, and wildlife that has adapted to cold instead of heat, but faces the same challenge of scarce water. Deserts are also places of wonder at night. With little moisture and almost no artificial light, the skies above them are some of the clearest on Earth. The Milky Way arches across the heavens in dazzling clarity, and shooting stars streak silently overhead. For thousands of years, humans have looked to the desert sky for guidance, for stories, and for meaning. The silence of the land seems to amplify the voice of the stars. Despite their reputation as barren, deserts are vital to Earth's balance. They shape wind patterns, store minerals, and serve as migration corridors for birds and animals. Even the dust of the Sahara travels across the Atlantic, carrying nutrients that fertilize the Amazon rainforest. In this way, the lifeless sands of one continent breathe life into the lushest forest of another. To walk in a desert is to feel small in the presence of time. Footprints vanish quickly, erased by wind, as though reminding us that nothing lasts forever. Yet in that impermanence lies beauty. Deserts teach patience, resilience, and humility. They remind us that life does not need abundance to thrive. It only needs adaptability and quiet strength. The silent kingdoms of sand and stone are not empty. They are waiting, listening, holding stories older than we can imagine. Every dune, every cactus, every mirage is a reminder that Earth holds beauty not only in abundance, but also in scarcity. Deserts whisper that even in stillness life endures.